Hello again. This is my second video demonstrating neo1620, my Linux application for essentially simulating a 1960s computer known as an IBM1620. What I'm going to be doing today is demonstrating how to use the 1620's operating system from the 1960s called Monitor 1 to assemble and execute an SPS program. The program was sent to me by Paul Kemple, and what it does is calculate digits of pi. So let's get started and start the 1620 simulator. I'll touch the power button, F1, power light comes on, the ready light will come on in a few seconds. What I want to do now is execute a console command called CEXE, which does essentially a 1622 load operation, which is reading numerically into location 0 and then branching to 0. This uses the virtual card reader. The way that I'm starting monitor up, it will assume control statements are going to come in through the card reader. When I launched Neo just now, I gave it some run parameters that tell it about the virtual I/O devices, and there's one called iDevice5, which is the virtual card reader, and I have pointed that to a Linux file which looks like this. It's just an ASCII text file. The first line of it is the Monitor 1 boot, and that's followed by Monitor 1 control statements, and then SPS control statements, and then finally the source statements for the SPS program. So let's type in the CEXE command and get monitor started. Neo has told me in the master output window that it wants a mount or an insert of a flash drive which contains the virtual 1311 disk pack. So let me put that in. All right, that has satisfied it. And monitor 1 is now cranking away, and it has echoed the three control statements that it read through the virtual card reader, and it shows them there in the typewriter output window. There's a job statement, a comment statement, and then the SPS X control statement. And SPS is now reading and assembling the program. This will take about another 30 seconds or so, and then the program will execute. Oh, there we go. And now the program is executing. This program takes Neo about 15 minutes to run. Paul says that when he runs it on his simulator, it takes about 20 minutes. I'm not going to show the entire execution because it looks pretty much the same. At some point, I'm just going to suspend the recording and then resume it when it gets within a minute or two of the end, so you can see how the program terminates. And now we see the program has quickened considerably. When we first started the program, it was taking 11 or 12 seconds for each group of 4 digits. But now it's much quicker than that. And it's done.